Hey Huskies, in this video we are going to take all the good stuff that we've been practicing when working with mixed numbers and improper fractions, as well as adding and subtracting fractions with the same place value or denominator. And we are going to apply that to working with different place values or different denominators. So specifically in this video, we're going to look at halves, quarters, and eighths. So if we look at kind of our steps on the right-hand side of the screen, the videos on mixed numbers and improper fractions, as well as adding and subtracting with the same denominator, really focused on step one. How do we make sure that all the numbers look the same when we are adding and subtracting? The focus of this video is really to start looking at, okay, if all of my numbers look the same, I still have to make sure that they all sound the same, so they have the same place value or same denominator. When we were working with decimal numbers, a big part of this was comparing tenths and hundredths, for example. And when we're working with tenths and hundred, there's a nice relationship there. 100 is 10 times larger than 10. And we've picked halves, quarters, and eighths to start working with for a very similar reason. 2, 4, and 8, and even if we think of our multiplication tables, we often learn our 2 times, 4 times, and 8 times multiplication fact first because they share a really strong relationship. 4 is the double of 2, and 8 is the double of 4. So before we dive into adding and subtracting, it is important that students spend some time creating some equivalencies, understanding how to compare halves, quarters, and eighths. And at the beginning, we're really going to encourage students, if they don't automatically see the relationship between the numbers, to rely on pictures or manipulatives or something that they can kind of see and feel in order to build those equivalencies. It's really, really important. So let's start with 1/2, and we're just gonna draw 1/2. So I have 1 whole, that's what my rectangle represents, and then I'll color in 1/2. And that's gonna be kind of our starting point to see how we can compare halves, quarters, and eighths. So if I wanna ask myself, in 1/2, how many quarters are there? I can draw a picture to represent that relationship. So I'll start with the 1/2 that I built at the beginning. And then if I see the relationship between 2 and 4, which is double, that relationship tells me that if I want to take the picture I've drawn representing 1/2 and I want to change it to represent quarters, I will need to cut each piece into 2. So if I go across and I cut my halves into 2 pieces each, what I can see is that I have 4 total pieces, which is great because I want to work with quarters. And of those 4 pieces, 2 of them are colored in. So what I've just drawn here is just a visual representation of the relationship between halves and quarters, and I can now say comfortably that in 1/2 there are 2 quarters. Now, if we extend that to working with eighths, we also want to ask ourselves, in 1/2, how many eighths are there? And I'm going to start with the exact same picture. I have 1/2. I kind of look for my relationship between the numbers. So 2 times 4 is 8. And that tells me that to take my picture and go from halves to eighths, I have to cut each piece into 4. So I'll start by cutting it into quarters again, and then I'll cut each piece into 2 more. And now I really have 8 pieces. I can count them: 1, 2, 3, 4, 5, 6, 7, 8, which is great because I'm working with eighths. And of those 8 pieces, 4 of them are colored in. So what I've shown here with my picture is that in 1/2, there are 4 eighths. And in class, I always take the opportunity to bring this back to what students know about their multiplication and division facts. So 1/2 is equal to 2 quarters, for example, because 2 is half of 4, and 4/8 is equal to 1/2 because 4 is half of 8. So although we're starting to work with fractions and place values that are kind of really nice and work well with each other, it's not unreasonable in grade 7 to ask students to compare 1/2 with other place values or other denominators. So for example, if I ask students how many 84ths in 1/2, their knowledge of division and multiplication, and now of fraction, should make them feel comfortable that because 42 is half of 84, that 1/2 is equal to 42 84ths, or 42 over 84. And that might seem like a stretch, but it's a really important understanding for students to develop, that there is always a relationship between our numerator and our denominator that can help us understand questions differently. So in class, students will have access to kind of a placemat that they can use at the beginning to help them compare halves, quarters, and 8. I'll flash it up on the screen right now. With the expectation that with practice, they can either draw their own pictures if they need to, or that they really start to understand the relationship between the numbers, what in school I would have called finding common denominators or the least common denominator, and kind of get to those procedures themselves so that they understand where they come from. Really important with fractions and decimals that students always have something to fall back on if a problem or a question is difficult. And in this case, we're gonna really focus on the relationship between numbers, and if needed, drawing the pictures. So building that understanding before we start practicing and introducing all of the procedures. So now that we've compared those numbers, let's go look at one adding example and one subtracting example of the materials, the practice materials that you can find on the website. So while we're looking at our first addition questions, we're going to follow the steps that are written on the right-hand side. So step 1, like we've practiced in other videos, we want to make sure all the numbers look the same. So in this question, we have a mixed number and an improper fraction. Students are really being encouraged in class right now to find out which type of number they're most comfortable with and try and practice that as much as possible. So do you want everything to be mixed numbers, or do you prefer everything being improper fractions? I personally prefer everything being written as an improper fraction, so that's what we'll do for this example, but students are always encouraged to use whichever they prefer as long as it works for them and the question. So I will start by taking 2 1/2 and switching it to an improper fraction, 5/2, and 5/4 is already the same. Now, going from 2 1/2 to 5/2 is really explained in details in the previous videos, so we're not going to spend a lot of time with that here. What we want to spend a lot of time on is, now that both my numbers look the same, I want to go to step 2 and make them sound the same. I'm working with halves and quarters in this example. Both of them need to sound the same. So we need to go ask ourselves, in 5/2, how many quarters do I have? So again, students might have already built an understanding of how to compare halves and quarters using their relationship, their multiplication and division. But if they don't, it's still completely appropriate for them at this point to go and represent these numbers using pictures. So I've broken up whole numbers into halves, and I'm just going to go represent 5/2. And now I want to change all of those rectangles into quarters. And again, because my relationship between 2 and 4 is double or times 2, that tells me that I've got to go take each of my rectangles, each of my halves, and cut them into 2 pieces again. And then I can just go count how many quarters I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what I've shown is that 5/2 is the same thing as 10 quarters. And again, I'm going to slow down here and really try to impress the importance of allowing students to build this understanding understanding why the procedures that we remember from school work, because it is important, right? If students ever forget any of this, they need something to fall back on, something to allow them to retrain their brain. And the only way to do that is if we really understood something, not necessarily by just knowing the procedures without understanding. So let's go rewrite our question here to make them all look and sound the same. So now I have 10 quarters plus 5 quarters. And this is where the question now looks identical to the last step, where we were adding numbers with the same denominator. Because I'm adding quarters and quarters, I can rely on what I know about whole numbers. 10 plus 5 is 15. 15 what? 15 quarters. And at this point in their learning in grade 7, we are accepting an improper fraction as an answer, but lots of students are seeing the relationships enough that they might automatically rewrite this as 3 and 3/4, but both are completely acceptable at this point. So let's go take a quick peek at our subtraction example on the next page. So before we look at the piece on subtraction, students hopefully will practice and get comfortable enough with the steps that are listed on the right-hand side to start to recognize that even though these are called step 1 and step 2, they're actually interchangeable. Once students get comfortable making the numbers sound the same, so placing numbers, writing numbers with the same place value or denominator, they might actually find it a lot easier to do step 2 before step 1. So with the question we're looking at, for example, we are working with eighths and quarters. So before even looking at, how do I want the numbers to look? How am I going to solve this question? I'm just going to right away, go and make sure they have the same place value. So in this case, I want to ask myself in 3/4, how many eighths are there? Once again, students might have already developed an understanding of the relationship enough to just know how many eighths there are in 3/4, but if not, they can always still certainly draw a picture. So I have 3/4. Because 8 is the double of 4, I know that I have to cut each piece or each quarter into 2. And now I have my 8 pieces, and of those 8 pieces, 6 of them are colored in. So I'm going to right away go rewrite my equation as 3 1/8 minus 1 6/8 is equal to what? So as I've mentioned in other videos, subtraction is often the most complex of the 4 operations for students. So because of this, I really do want to solve this subtraction in 2 different ways. We're first going to solve it using only improper fractions, and then we'll leave it with mixed numbers and look at that on a number line, which is the strategy students will typically go to if they are using mixed numbers. So let's start with improper fractions first. So 3 1/8 is the same as 25/8. So I have 3 wholes multiplied by 8 pieces, and then I have an extra. Minus 1 6/8 is the same as 14/8. Once again, to follow the steps to go from mixed numbers to improper fractions is in other videos. So we're just kind of skimming here at this point. And now, because my numbers look the same and the place values sound the same, the denominator is the same, I can use what I know about whole numbers to do 25 minus 14, which is 11. And then I ask myself, 11 what? 11/8. Again, students are more than welcome in grade 7 to keep their answers as improper fractions, but if they are seeing those relationships already, might choose to write it as 1 3/8. In this question, however, because the numbers already look the same at the beginning, they're both mixed numbers, lots of students will choose to keep them as mixed numbers, which is fine. And the strategy we'll see most often, if they do, would be to represent the difference on a number line. So I have 1 6/8, 3 1/8, and I want to find the difference between the two numbers. So I will benchmark 2 and 3. And what I like about using the number line in this situation is that it's a very similar strategy to our decimal numbers and whole numbers. So students sometimes find some comfort in that. So now I'll just go ahead and identify my partial differences on my number line. So the difference between 1 and 6/8 and 2 is 2/8. Between 2 and 3 is 1. And the difference between 3 and 3 and 1/8 is 1/8. And to find the answer, I just have to go and add all of those numbers together. So 1 plus 2/8 plus 1/8, no surprise, gives me the same answer as when I worked with improper fractions of 1 and 3/8. So again, before we finish, I just want to take the time to clarify how important it is that students use these beginning steps of fractions in grades 7 and 8 to really build a good understanding and to build comfort when working with fractions. Fractions aren't going away in their math classes. They'll keep coming back in high school. And in some cases, they'll keep getting more and more complex. So it's really, really important for students to work with manageable fractions, to work with fractions that they can draw out, they can represent, and just build an understanding before we start to look at all of the procedures or rules or steps that we can follow when we're working with fractions with different denominators. As always, you can find practice materials by clicking on the button below the video. Thanks for watching.